Thanks for joining me on our final field trip, where all you have learned about geology comes together and is applied in uncovering the geologic history of this area. We will be exploring the outcrops of eastern Missouri, starting near Alton, Illinois, and heading back in time to the Precambrian. What did this region look like in the Pennsylvanian, or the Ordovician, or the Cambrian? Did volcanism take place? Were there vast inland seas? Where did folding and faulting occur? Let's take a field trip to see the evidence these events have left behind. Our first stop is at an outcrop 25 minutes from campus, just south of the Mississippi and Missouri rivers, off Highway 367. Here on the shoulder, we see an outcrop of exposed rock. There are two types of rock in this outcrop. The first rock type has sand-sized grains and fizzes when hydrochloric acid's dripped onto it. The second rock type is very fine-grained and light gray and fizzes as well. Using our sedimentary rock identification key, we can identify these rocks as calcarenite, limestone, and micrite. Using our local section descriptions, we can identify this outcrop as part of the same St. Louis limestone beds which we saw in the cliffs at Alton. In the median of Highway 367, we find exposed oolitic limestone with pockets of sandstone that do not fizz. These sandstone rocks show signs of crossbedding, visible here as layers which intersect at different angles, as well as ripple marks on the exposed eroded surfaces as seen here. Pause the video here and record the formation name and age, such as Mississippian, based on our observations of the rock types which we found at this outcrop, as well as the sedimentary structure we saw. List the rock types and sketch the sedimentary structure in your field notes as well. Pause now. Our next stop, stop 2, is a half-hour drive south on I-270 to the Olive Road northbound on-ramp. There's a wonderful outcrop right next to the freeway here. The rock here consists of sand-sized grains with lots of fossils. You may want to pause the video to identify some of the fossils in these pictures. Can you spot the crinoid stems in this rock? Drops of hydrochloric acid fizz on this rock. Other rocks here are very, very fine-grained or even microcrystalline, but also fizz when hydrochloric acid is dropped onto them. Fossils seen here include these brachiopods, echinoids, crinoids, and even these fusellinids, which are guide fossils in our local section. Pause the video here and record the rock types and fossils observed here as well as the formation name and age this bed must be, based on your field notes and local section notes. Pause now. Our next stop is 20 minutes to the south on the I-55 off-ramp from I-270. Walking around the back to the top of this outcrop behind the bushes, we find an outcrop of very light gray microcrystalline rock and some breccia. To determine the rock type, let's chip away to get a hand sample of this rock and drip some hydrochloric acid on it to see if it fizzes. The weathered top surface of this outcrop reveals tons of fossils of echinoid spines, as well as their attachments or ball and sockets. You may want to pause the video to take a look at some of these images more closely. Here you can even see the feathery tops of the echinoids. Pause the video here and record the rock types and fossils observed here, as well as the formation name and age this bed must be based on your field notes and local section notes. Pause now. Our fourth stop is at the Barnhart exit from I-55. We'll be looking at rocks at 5 different spots along this outcrop. North of the off-ramp, the outcrop starts off as a crumbly slope. The very fine-grained, light gray rock breaks into thin slabs that don't fizz. Graptolite fossils shown here are found on these slabs. Hiking up to the upper part of this outcrop, we find maroon and greenish-gray crinoidal limestone, containing lots of fossils. Fossils such as these Spirifer gramesci and Burlington productids are found in these rocks. Here's a prime example of a Burlington productid fossil. These limestone rocks definitely fizz. At the beginning of the off-ramp, we see rock with sand-sized grains and fossils. These rocks contain burrows. These thumb-sized holes are the burrows of animals. This rock fizzes and contains some embedded chert nodules, which are these small yellow rocks seen embedded here. In addition to burrows, we find massive bryozoan fossils and these receptaculites fossils. Receptaculites were ancient sponges, and their fossilized remains resemble pincushions, as seen here. At the small outcrop about the middle of the off-ramp, we find thin-bedded micrite containing tons of fossils. As you can see here, this rock is microcrystalline. It also fizzes when hydrochloric acid is dropped on it. While not containing a ton of fossils, it does contain some very significant guide fossils, such as Hormontoma, seen here, as well as nautiloids, the straight kind, and this Zygospira brachiopod. Finally, just north of the stop sign at the end of the off-ramp, we drive by more micrite beds, riddled with pencil-sized holes. Pause the video here and record the rock types and fossils observed at each of the 5 locations along this off-ramp, as well as the formation names and their ages. Hint, each location around this outcrop showcases a different formation. Use your field notes and local section notes to identify these formations. Are there any missing formations? Why? What happened? List at least 2 hypotheses about how this could have happened. Our 5th stop is 15 minutes to the south at the Herculaneum off-ramp from I-55. The rock at this outcrop is white to yellow with sand-sized grains that weather easily to create quartz sand at the base. Use your sedimentary rock identification key to identify what type of rock this is. It doesn't fizz. Pause the video here and record the rock type observed here, as well as the formation name and age this bed must be, based on your field notes and local section notes. Our 6th stop is 10 minutes to the south on Highway 67. The rock at this outcrop includes thin slabs of orange to buff-colored rock. These slabs are fine-grained, almost sugary textured. This rock does not fizz, but powdered bits of it fizzes. Pause the video here and record the rock type observed, as well as the formation name and age this bed must be based on your field notes and local section notes. Between this stop and the next is a fairly large fault zone, with the south side going up. Our 7th stop is also along southbound Highway 67, just north of the entrance to St. Francois State Park. These rocks contain cavities called vugs, lined with quartz crystals, hence the name druzy quartz. The rocks weather to a red, cherty soil, seen here due to the iron in the rock. The rocks also contain the mineral barite. The rocks themselves don't fizz readily, but powdered bits of the rock fizz slightly. Pause the video here and record the rock type observed here, as well as the formation name and age that this bed must be, based on your field notes and local section notes. Our 8th stop is southbound along Highway 67, just south of the bridge over the Big River. The outcrop lies on the other side of the highway, but we can see from here that there are 2 beds, an upper bed of medium-bedded dolostone, overlying a lower bed of thinly bedded dolostone, the interbedded with shale. Which formation is this? Record the name of the formation in your field notes. The contact between these 2 beds is obvious under the white power pole to the right of center in the frame. You can see a deep shadow under the overhang of the top bed. This boundary correlates to the slight overhang seen in the left-hand edge of this frame, halfway up the bare rock of the outcrop. Following this boundary to the right, it runs into the ground below the black billboard pole in the center of the frame, before being offset upwards to reappear as the overhang below the white power pole. The section of outcrop below the black billboard pole is a fault zone of ground-up rock. You can trace the contact between these two beds from left to right in this video. Pause the video here and sketch the bedding and fault relationship in your field notes. Be sure to include the direction of motion on the fault. Our ninth stop is at the on-ramp at the intersection of Highway 8 and 67. This outcrop contains fine and medium-grained, medium-thick bedded, sugary textured rock with no chert and no druzy quartz inclusions. What kind of rock do you think this is? While powdered bits of this rock fizz, the rock itself doesn't fizz. Pause the video here and record the rock type observed here, as well as the formation name and age this bed must be, based on your field notes and local section notes. Pause now. After heading east on Highway 32 for 45 minutes, we come to our 10th outcrop at the intersection of Highway 32 and the frontage road west of I-55. The rock here appears to be very fine-grained, mottled, with dolomitic burrows that weather out to form pencil-sized holes. A way to get a hand sample of this rock, we find that the rock fizzes quite readily. This may help you identify the rock. There are lots of fossil fragments to be found in this outcrop, including orchids, snails, trilobites, and corals. Pause the video here and record the rock types and fossils observed here, as well as the formation name and age this bed must be, based on your field notes and local section notes. Stop here and mark a symbol for each formation, as well as the geologic time for each formation, on your map in your field notes. I hope that you notice this formation contains fossils again, whereas the last couple outcrops were from more ancient formations without fossils. This formation is one that you've encountered already at a previous stop along the field trip. You should be able to draw a line connecting this outcrop to the same formation in an earlier outcrop. Based on the information plotted on your map so far, draw some contact lines joining formations. Stop number 11 is at the intersection of routes N and P on the furthest eastward border of our field research area. Here we see some gray rock with sand-sized grains. Some grains are larger than others. This is interspersed with light buff rock that's extremely fine-grained and hard. Here we see that the gray rock fizzes, while the tan rock does not. The gray rock is chock full of fossilized crinoid stems, like the white circle seen in the middle of this rock, as well as fossil imprints of productids. Pause the video here and record the rock types and fossils observed here, as well as the formation name and age this bed must be, based on your field notes and local section notes. Our 12th stop is at an outcrop along Route P, next to a dirt driveway leading into a fenced field. The farmer who owns this land has graciously allowed the public, including geology tours and news camera crews, to visit this outcrop. It's one of the world's best examples of a particular fossil. Do you recognize this fossil from a previous outcrop? See if you can identify it from the following images of it in this rock. Here is our Illinois fossil identification sheet, useful for identifying and naming this fossil. Did you correctly identify it? This fossil is in the same type of gray rock with sand-sized grains that fizz, which we saw at a previous outcrop, although this is a different formation. Pause the video here and record the rock type and fossil observed here, as well as the formation name and age this bed must be, based on your field notes and local section notes. Now pause again and annotate the names of the formations next to each stop on the sketch on your field notes. What's missing here? Sketch in a probable solution on the diagram and list the sequence of 5 events responsible for creating this solution. Finally, look back at the observations at stop number 4. Which of the hypotheses, or a couple of reasons that you listed there, are most likely? Stop number 13 is along Highway 67, south of the intersection with Route W in Farmington. Notice the light tan, thinly bedded upper layer on top of the gray block below. What types of rocks are in these 2 layers? Let's take a closer look at the contact between these 2 layers. The red rock seen here is an inclusion into the upper sandy layers. The principle of inclusion should help you in determining the relative age of these beds. Starting at the bottom of the outcrop, we see a phaneritic rock with pinkish potassium feldspar, black amphibole, and white quartz grains mixed together, making this which type of rock? Above this pinkish phaneritic rock, seen on the bottom half of the outcrop, we see a narrow yellow band of rock, topped by a whitish sandy rock at the very top of the frame, with the red rock stuck into it as an inclusion. The whitish sandy rock is streaked with red staining as well. The potassium feldspar is staining the sandy quartz grains of this sedimentary rock pink. Neither type of rock here would fizz. Pause the video here and record the rock types observed here, as well as the formation name and age these beds must be, based on your field notes and local section notes. What sequence of 4 events would have created these 2 beds like this? 15 minutes further east, we come to stop number 14 along Highway 72, just west of the turnoff from Highway 67. In the middle of this outcrop, we see a black stripe. Visible here. On either side, we see dark maroon-colored rock. How can the principle of cross-cutting relationships be applied here? The black stripe cuts through this outcrop from top to bottom. Looking closer, we can see that this maroon rock is aphanitic. No grains are visible at all. Taking a hand sample, we find this rock is very hard, doesn't scratch, and contains some pink porphyries of potassium feldspar and white porphyries of quartz. Using our igneous rock identification key, what kind of rock would this be? Looking now at the black rock, we see this rock is similarly aphanitic, but grayish-black in color. Using our igneous rock identification key again, what type of rock would this be? Looking at this same outcrop on the other side of the highway, we see maroon blocks cut by the same black dike. But here we see it's overlain by a boulder conglomerate comprised of boulders weathered off of the maroon rocks. And on top of that, toward the left-hand side, we can see a layer of sandstone, grading from arcadia pink to quartzose-ish white as it goes up. Driving a little further west from this outcrop, we'll begin to see some medium-grained, medium-thick bedded dolostones, which are sugary textured. Pause the video here and record the rock types observed here, as well as the formation name and age these beds must be based on your field notes and local section notes. Also sketch the relationships between these beds in your field notes. Stop number 15 is my most favorite stop on this field trip, Elephant Rocks. Elephant Rock State Park is an exposed Precambrian granite batholith. It's part of the protocontinental landmass formed during Earth's earliest history, before the landmasses had even joined together to form the supercontinent of Rodinia near the equator, later splitting off to form continental landmass known as Laurentia. Terrains were accreted onto it on the east and the west, and parts of it broke off to become Australia, Africa, Siberia, Baltica, and Antarctica. Yet this massive batholith of granite remained. It was covered by billions of years of sediments which accumulated and eroded over and over again before being scraped clean during the last ice age, leaving this section of the granitic batholith exposed for us to climb on. These so-called elephants formed as the solid mass of granite cooled, contracting and forming vertical cracks, which later split off horizontal layers as the massive pressure from the overlying sediments were eroded away and scraped off. The release of this pressure caused the horizontal cracks to form, and the contraction from cooling caused the vertical cracks to form. As wind and water work their way into these cracks, freezing and expanding them, and scouring and rounding the edges, each cube between the horizontal and vertical cracks weathered to become potato-shaped. Thus, the elephants were created. Granite in these elephants may look gray and uninteresting, but it was quarried for building materials, and it's quite beautiful when polished. The remain of the quarry has been filled with water, but the path around it is lined with polished blocks of this granite, cut out of the quarry by the stonemasons who worked there. Leaving elephant rocks behind, we head north on Highway 21 to the town of Potosi, 45 minutes away. On an embankment below a Hardee's, we find a small outcrop of vuggy dolostone nestled in red soil. The vuggy nature of this rock refers to the holes found in the rock and large chunks of druzy quartz which are found in the bigger vugs. These vuggy stones do not fizz, but powdered bits of them do. Pause the video here and record the rock type observed here, as well as the formation name and age this bed must be based on your field notes and local section notes. Our next stop is at an outcrop at the corner of City Park in Rolla. Here we see thin-bedded, slabby, buff-colored dolostone. Where have we seen this before? Pause the video here and record the rock type observed here, as well as the formation name and age this bed must be based on your field notes and local section notes. In a minute, I'll ask you to pause the video again to create a preliminary map and cross-section and use these to predict the formations that you'll see in the remaining 3 stops on this field trip. No fair skipping ahead to the answers. Start by adding all of the formations and ages we've recorded at each of our stops so far on the sketch map onto the first page of your field notes handout. Then try to draw lines showing the boundaries between each of the formations exposed on the surface in this region of Missouri. It may be helpful to color in the areas of each formation exposed on the surface. You may use the key in the upper left corner of your sketch to color code the key for the different formations and ages. Finally, you'll use the map pattern that you have just created. Remember map patterns? To identify the geologic structure underlying this region of Missouri. In other words, is it an anticline, syncline, plunging fold, dome, or basin? Finally, record your predictions for the rocks that we'll find at stops 18, 19, and 20 of this field trip. Stop number 18 is at an outcrop near milepost 245 along I-44. Since I'm literally standing on the side of I-44 freeway, I don't have a long shot showing the placement of this outcrop. Up close though, this outcrop shows reddish, sandy-looking rock that doesn't fizz, but breaks down into red sand at its base. At the far end of the outcrop, we can see ripple marks on the exposed top surface of the outcrop. Pause the video here and record the rock type observed here, as well as the formation name and age this bed must be, based on your field notes and local section notes. Did this match your guess for stop 18? If you need to make any adjustments to your map based on what you identified, do so now. You may also make new predictions for stops 19 and 20. 10 miles further up I-44, at mile marker 255, we find an outcrop that is our stop number 19. The rock here is very crumbly white rock with coarse sand-sized grains. It weathers easily, creating piles of white sand at the base. In some spots, there is a very thin layer of friable green shale visible at the base. This sandy rock does not fizz. Pause the video here and record the rock type observed here, as well as the formation name and age this bed must be, based on your field notes and local section notes. Did this match your guess for stop 19? If you need to make any adjustments to your map based on what you identified, do so now. You may also make a new prediction for stop 20. Our last stop is at exit 269 off of I-44, 15 minutes to the north of stop 19. Most of the rock here is tan with sand-sized grains, which sparkle on their broken edges. Fossils found in this bed include these Burlington producted brachiopods. The smooth microcrystalline rock found here does not fizz, while the sparkly tan rock with sand-sized grains fizzes easily. Pause the video here and record the rock type observed here, as well as the formation name and age this bed must be, based on your field notes and local section notes. Did this match your guess for stop 20? If you need to make any adjustments to your map based on what you have identified, do so now. Using the clean copy of the sketch map, provided on the last page of your field notes packet, create a carefully drawn geologic map of this region of Missouri, using colors to differentiate the beds and appropriate symbols for the units marked on the map, following the key in the upper left corner. Provide a clear legend identifying the colors used and the types of rocks found in each unit. Using those same colors for each unit, draw a cross-section for the area. You will submit your geologic map and cross-section, as well as your completed field notes for this field trip online. I hope you have enjoyed applying your geological knowledge to deduce the geologic history of this fascinating region as we have explored it on this virtual field trip.